Hi, I'm going to show how you debug your program. This is the fourth page from the bottom in the PDF file. When you compile and download your design into D10 Lightboard with the test1 program, this is going to be the default status when the addition instruction, which is the first instruction coming into the IF stage, program counter will be 0, PC plus 4 is 4, and instruction value is A74020. Please note that it just to show last 6 hexadecimal digit because we have only 6 7-segment LED. So let us see if we really have those values on the real board. Okay, so I'm going to move up this switch to the top, the last switch to the top, in order to indicate the IF stage. So IF stage program counter value is 0 when the switch 1 and 0 is 0, and I just move up the switch 1 to the top. That gives you PC plus 4. Okay, so PC plus 4 is going to be 4, right? And I switch 1 and 0 to 0, 1, that will shows you the instruction. And the instruction, as you see, the last 6 hexadecimal is going to be A74020. Okay, and now let us move back to 00 status and keep the last digit as IF stage. Okay, and let us move on to the next clock. So I'm going to press key 0 to proceed 1 clock. Okay, and now you see the program counter is going to be 4, and the PC plus 4 is going to be 8, and instruction is going to be 044822. Again, this is the last 6 hexadecimal digit. Okay, and at this point, we want to see what are the signal in ID stage. Okay, so in that case, I'm going to make the last switch to 0 and move the second switch to the top. So which means that we are seeing the signal in ID stage. Okay, so if the switch 0 and 1 is 0, 0, it shows you RT and RD. As you know, this is an addition 857. So RT is a 7, RD is D. So that's what you see on the 7-segment LED. And if I move the switch 1 and 0 to 0, 1, you will see the RD1, which is the first source register number. In other words, register 5. So register 5 is default value is 84. That's what you see. If I move on to switch 1 and 0 to 1 then 0, then you will see the default value of register 7, which is the second register. As you see, that's 1. If I move up to switch 1 and 0 to 1, 1, you will see PC plus 4. So in this case, this is the 4. Okay, and that's exactly the second stage after in cycle 2. Okay, when the subtract instruction is in the IF stage and addition instruction is in the ID stage. So when we adding one more clock, it will move up to the clock cycle 3, and you will see this part. Okay, so when the addition instruction is in execution stage, subtraction is in ID stage, and AND instruction is in the IF stage. Okay, so you will see in IF stage, PC plus 4 is a C, and the instruction the 32-bit instruction, particularly the last 6 hexadecimal digit, is C85025. And in ID stage, subtract instruction is executed. You know, the RT/RD is a 4 and 9. The PC plus 4 is 8. RD1 is a 0 because register 8 is a 0. Register 4 is a 4. And also in execution stage, addition instruction is there. The result of this addition operation is going to be 85. And RD2 is 1. RD destination register is 8. So you will see all those numbers, okay, in the D10 light board. So let us move on, go back to the IF stage again. So let me just move up to 1 and 0. So it is going to be, this is 1 and everything else is a 0. And let us see what is the, you know, first of all, we need to proceed to clock cycle 3. And as you see, the program counter is 8, PC plus 4 is a C, and instruction, 32-bit instruction is a C85024. Again, this is the last 6 hexadecimal digit for AND operation, which is in IF stage. And now let us look at the ID stage at this point. So I just to change this signal, switch 8 to 1 to see the ID stage signal. Okay, when 0 and 0, that's going to be RT/RD, which is a 4 and 9. And if I move on to switch 1 and 0 to 1, 0 and 1, it will show you RD1. 1 and 0, you will see RD2, which is a 4. If I move on to 1 and 1, that will shows you PC plus 4 in the ID stage. And then since the first instruction is already in the execution stage, I need to change this signal, switch, and this signal. So which means that we are seeing the signal in the execution stage because, you know, 9, 8, and 7, 6, 5 is 0, 0, 1, 0, 0. Okay, and the switch 1 and 0 indicates when you move on to 0, 1, that will 1 and 0, 1, that's going to be 85, as you see. And 1 and 0, that will give you 1, which is RD2. And 1 and 1, that's the destination register number, which is 8. Okay. So I'm going to stop now, but the point is that whenever you proceed the clock using key 0, you can actually see all the signal in those 5 stages to see whether your design is working correctly or not. Okay, thank you. Bye.